Hello guys, in this video I'm going to show you guys how to write the proof for the statement the square root of any irrational number is irrational using the method of proof by contradiction. So here I have a couple of steps on how to write a proof by using the method of proof by contradiction. First, you want to suppose that the statement to be proved is false. That is, suppose that the negation of the statement is true. So the first thing you want to do is you want to write this sentence in if-then form. In doing so, you can take the negation of the if-then form easier than taking the negation of this statement as is. So it says the square root of any irrational number is irrational. We're dealing with one variable since it just says any irrational number. So I could say if m is an irrational number, then the square root of m is irrational. So we have this condition right here, which means P implies Q with this guy being P and this guy being Q. If we take the negation of it, if we take the negation of the condition, the negation of P implies Q is equivalent to P and not Q. That being said, the negation of this if-then sentence will be m is an irrational number and the square root of m is, instead of irrational, it'll become rational because the negation of irrational is rational. So the first thing you want to do is take the negation of the statement, which is what we did, and then you want to suppose that it is true. So in our proof, we're first going to write suppose, and then we write the negation. So suppose m is an irrational number and square root of m is rational. That's the very first sentence of our proof by contradiction. So you take the negation of the initial statement and suppose that that negation is true. Now the next thing you want to do is you want to define the definitions. So the technical terms that not everyone understands are irrational and rational. Everything else here is fine. So if we look at the definition of rational and irrational, a real number r is rational if and only if it can be expressed as a quotient of two integers with a non-zero denominator. A real number that is not rational is irrational. So r is rational when there exists an integer a and an integer b such that r equals a over b and b is not equal to 0. So as it says here, if a number can be expressed as a quotient of two integers with a non-zero denominator, then that number is rational. We don't have that much to work with for irrational though, because the definition just says a real number that is irrational is a number that's not rational. So we would want to focus on rational since it has a more descriptive definition. So it says here, and the square root of m is rational. So let's focus on the square root of m is rational. So we could say by definition of rational, the square root of m equals some integer over some integer, where the numerator and denominator is an element of the set of integers, and the denominator is not equal to 0. Now we want to show that m is an irrational number. So we could derive m since the square root of m squared is equal to m. So we could say, then the square root of m equals a over b, where a, b are integers, and then if we square it, then m equals a squared over b squared, and a squared and b squared are elements of the set of integers because integers are closed under multiplication. Meaning, if you multiply integers together, the product is an integer. So here we showed that a and b are integers, and a squared and b squared are a times a and b times b, so an integer times an integer, the product is an integer. So we just proved that m is the quotient of two integers. So we could use this definition to say, since m can be expressed as a quotient of two integers with a non-zero denominator, this means, I should probably put right here that b squared is not equal to 0, since if b is not equal to 0, then b squared isn't equal to 0. To address this part, since m can be expressed as a quotient of two integers with a non-zero denominator, this means m is rational. Right? But hold on, we said up here that m is an irrational number, but here we're saying m is rational. So this right here is a contradiction. We told the reader at the beginning that m is irrational, but here we're saying that m is rational. We just proved that m is rational. So then we could say, this means m is irrational and rational. This means m is irrational and rational, which is a contradiction. Because you can't have a number that's both irrational and rational. It's either one or the other. So then you say your last sentence. You say thus, and then you restate the original statement. Because we supposed that the negation is true. We proved that the negation is false. So if the negation is false, then the negation of the negation, which is the original statement, must be true. Thus, the square root of any irrational number is irrational. And then you put a little square right here to indicate that your proof is done.